Welcome to another physics class. We've started the topic in our last lesson, energy. And when we concluded, we shown that the potential energy, PE, that the magnitude is given as mgh. That is where m is equal to mass of the body, g is acceleration due to gravity, and h is the height of the body from the horizontal level. Now, we now say that the factor that will determine the potential energy of a body depend on these three factors, that is the mass of the body, acceleration due to gravity, and the height of that object from the horizontal level. That is for potential energy. At the same time, we said kinetic energy, the magnitude is given as half mv square. That is, the magnitude of kinetic energy also now depends on mass and the velocity of an object. So also, before we concluded on that day, we proved to you that the work done can be equal to Ke, which is equal to half mv square. So today now, we want to look at examples. Calculation example under this one before we move to another thing. Now, example 1. Now, calculate the potential energy of Kanji Dam if the height is 200 meters and the mass of the water is 5.0 kg, G is equal to 10 meters per second square. Now, from this simple question now, we can now say that we have to calculate the potential energy, P. We have to calculate potential energy, but from the question, mass is given. F is equal to 5 kg. Then the height is given as 200 meters. Equal to G is given as 10 meters per second square. Now, put down our formula now. PE, according to what is on the board, mgh. So this one will now give for 5 multiplied by 200 multiplied by 10. Multiply everything together. This one will be 5 multiplied by 2000. Then 5 multiplied by 2000 will now give us 10,000 Joule. That is the PE of Kanji Dam according to this calculation. Take this one as example 2. A bullet of mass 100 grams leaves the barrel of a gun with a speed of 300 meters per second. Calculate the kinetic energy of the bullet. So, solution to this one. Now, we have to calculate kinetic energy, Ke. And within this question, mass is given. Mass, M, as 100 grams. But mark you, the speed is given as 300 meters per second. So we need to convert this one to kg. So convert it to kg, that divided by 1000, that's 0.1 kg. Velocity is given, speed, v, as 300 meters per second. Now, the formula to calculate kinetic energy, as I've written on the board, is half mv square. So this one will now give us half multiplied by 0.1 multiplied by 300 square. And 300 square will give us 90,000. That is half multiplied by 0.1 multiplied by 90,000. Now, this one will be 0.1 multiplied by 45,000. And the final answer for the kinetic energy equal to 450 Joule. Now let's take this one as example 3. A ball of mass 1.8 kg is dropped from 28 meters above the ground. Calculate the 1. Potential energy before it was dropped. 2. Speed with which the ball hits the ground. G is equal to 10 meters per second square. Now from this question now, question number 1 says we should calculate P, which is potential energy. The parameter given, mass is given as 1.8 kg. Then height is given 28 meters. Then again, G is given 10 meters per second square. So from there now we will be able to calculate the potential energy as P from the formula on the board is equal to mgh. And now our M is 1.8, then G is 10, then height is 28. Multiply all together, then this one will now give us 504 Joule. That is the potential energy when the ball dropped from this 28 meters above the ground level. Now the second question says we should calculate the speed with which the ball hits the ground. 2. Speed. Now, this one now will now lead us to what we call the energy transformation, which we are still coming to after this one. By the time the ball is about to hit the ground, all the potential energy will have converted to kinetic energy on hitting. Before hitting the ground, or the P will be transformed to kinetic energy. And if that is the case, from this statement now, P will be equal to half mv squared. Mind you, the question says if you calculate the speed. So from this one now, and luckily P is already known. That is 504. That will be 504 is equal to half. The mass is the same, 1.8, then multiplied by v squared. So if we cross multiply this one, that will now give us 504 multiplied by 2 is equal to 1.8 v squared. And this one will now give us 1008. That will be equal to 1.8 v squared. So our v squared now will be equal to 1008 divided by 1.8. So from there, our v now will be equal to square root of 1008 divided by 1.8. Our v now, which is the speed of the ball, will now give us square root of 560. And the square root of 560 will give us 23.666. Approximately, phi will now be equal to 23.7 meters per second. That is the speed of the ball before hitting the ground. Now, the next thing is mechanical energy. Already, don't forget, during our last lesson, we made mention of different forms or types of energy. We mentioned about 10. The typical example of them is mechanical energy. So out of those forms of energy that we have mentioned in our last lesson, the one we are concerning under this topic now is mechanical energy. Later, we'll move to other forms of energy. Now, when you say mechanical energy, this is the form of energy that we use in our daily activities. That is the forms of energy we use in our daily activity. That is, the energy we engage in our daily activity is what we mean by mechanical energy. Examples of mechanical energy. Examples of mechanical energy. 1. Walking. That is, when you walk from one point to another like this, you are making use of mechanical energy. You move from one point to another. You are making use of mechanical energy. 2. Moving vehicle. That is, when vehicle is on motion, is making use of mechanical energy. 3. Moving part of machine. When any part of a machine is moving, is mechanical energy. 4. Climbing a slant. Climbing a slant hill or mountain, we make use of mechanical energy. Number 5. Swinging of simple pendulum bob. That is, when it is being swung to and fro. That is, from this diagram, when you have a pendulum bob swinging to and fro. This is a typical example of mechanical energy from this point to this point and back to the original point. That's the typical examples of mechanical energy. 6. Motion of pendulum wall clock. At the same time, the pendulum wall clock will move in the same direction, to and fro. All these ones are typical examples of mechanical energy. As we said during our last lesson, that all forms of energy are potential and kinetic in nature. So, to talk about type of mechanical energy now, types of mechanical energy. When you say type of mechanical energy, that is, we have 1, which we have discussed before, potential energy. 2, kinetic energy. Don't forget, we discussed about this one in our last lesson. And that is why, if you are just joining us, to understand this topic better, please try as much as possible to watch our last video on energy so that you join into this one, be able to understand. So this is the 2 types of mechanical energy now. And don't forget, as I said, All forms of energy are categorized by these two types, that is potential and kinetic energy. That is, to take any other form of energy like electrical energy, you can have electric potential energy under electrical energy. That is, when you have charge at rest, then you will talk about electrical potential energy. When you have charge on motion, you talk about electrical kinetic energy, and so on. So not only mechanical energy have these two types. Next is energy transformation. Energy transformation. That is, what we mean by this is that all forms of energy, one can be transformed from one to another. That is, one form of energy can be transformed to another one. That's what we mean by energy transformation. Examples of energy transformation now. Example. 1. Telephone, earpiece, or microphone. Microphone, transform electrical energy to sound energy. That is, when you are making use of microphone or earpiece, it will transform electrical energy to sound energy. 2. Electric motor transform electrical energy to mechanical energy. That is, electric motor transforms electrical energy to mechanical energy. 3. Please take note of all these devices because of objective question. 3. Generator. The generator we are using at home or at office, you transform mechanical energy to electrical energy. That is number 3. Note this one too. Then number 4. Dynamo is another instrument. Dynamo. This one will transform mechanical to electrical at the same time, from electrical to mechanical. That is why we call it dynamo. Transforms electrical energy to mechanical energy, and vice versa, or mechanical to electrical energy at the same time. So it will transform electrical energy to mechanical and mechanical to electrical. That's why we call it dynamo. They serve these two purposes together. This one will only transform electrical to mechanical, that is electric motor. At the same time, generator will transform mechanical to electrical, while dynamo will serve the two purposes. 5. Application of car brake. Application of car brake transforms mechanical energy to sound and heat energy. That is, when car brake is applied, it will transform the mechanical energy within the car brake to sound and heat energy. 6. Electric lamp. Electric lamp transform electrical energy to light and heat energy. That is, when you on electric lamp, leave it for some time, immediately it will produce light, leave it for some time, touch it, it will produce heat. So it will transform electrical energy to light and heat energy. 7. A burning stove. Burning stove transform chemical energy to heat, light energy. That is, when a stove is being lighting, it will transform the chemical energy within the kerosene or anything you use as source of energy to heat and light energy. So, to mention but few, these are typical examples of energy transformation. That is how energy, one form of energy, can be converted to another by a specific device. Is conservation of energy. Conservation of energy. And this one will now lead us to principles of the conservation of energy. And the principle simply state that in an isolated or closed system, the energy can neither be created nor destroyed during transformation, or in an isolated system or closed system. When you say an isolated system or closed system, system that does not give out energy or receive energy. That's what meant by isolated system. So when you have such system, then energy can neither be created nor destroyed during transformation. Or simply you say the principle of conservation of energy state that in an isolated or closed system, the total energy is conserved. That is, it can be transformed from one form to another, but the total energy remains constant. That's the simple principles of conservation of energy. So let's write. states that in a closed or isolated system, energy can neither be created or destroyed during transformation. Energy can neither be created nor destroyed during transformation. That's the principle of conservation of energy. It's conservation of mechanical energy. As we said, the mechanical energy is divided into two, that is potential and kinetic energy. When you now say conservation of mechanical energy, to apply this principle now, the principle of this one now say that potential energy can be transformed to kinetic and kinetic to potential, but the total energy remain constant. I take it again. The principle of conservation of mechanical energy states that potential energy can be transformed to kinetic and kinetic to potential, but the total energy remain constant. That is the principle of the conservation of mechanical energy state that potential energy, P, potential energy can be transformed to kinetic and vice versa, but the total energy is constant. What? The total energy is constant according to the statement on the board. We are going to look at is energy transformation in mechanical system. The other time we made examples of mechanical system. Now, under this topic, we are going to stick to two examples. So, and the example we are going to use are examples of mechanical system. 1. A falling object. Falling object from certain height above the ground level. 2. An oscillating simple pendulum bulb. So we are going to use these two as an example to explain energy transformation in mechanical system. Now in the next class, we are going to use this example to explain energy transformation in mechanical system. And as I said earlier, if I just joining us, please don't forget to like, share, subscribe. So when I upload a new video like this, you're able to get the notification in time. Thank you.